BiCFlows combines hierarchical aggregation and filtering to support casual exploration of large bipartite graphs. The interface consists of the bipartite graph visualization, context bars to navigate in the bi-cluster hierarchy, bar charts to filter the data set, and lists of nodes in both sets to find and highlight specific entities. In the so-called media transparency database, all public authorities of Austria have to report their advertisement expenses to media companies above 5,000 euros, beginning from 2012. By 2017, the media transparency database contained 1,200 legal entities and 4,200 media organizations. In total, the database has more than 34,000 entries. BiCFlows reveals important legal entities and media organizations on the first glance. The two topmost labels show the legal entity Stadtwien and the media organization Krone spending and receiving the highest accumulated sums. These two network nodes are grouped into the same cluster with other popular Austrian newspapers, as well as other legal entities spending high amounts for advertisement in these newspapers. The second-ranked legal entity is contained in a different cluster. Selecting the cluster reveals that this legal entity mainly sponsors small radio and TV stations, from which most of them do not receive any advertisement money from other legal entities. When drilling into the data, a frequently occurring grouping reveals geographic proximity. Often, smaller legal entities tend to advertise in smaller, more local media. Other clusters are related topic-wise. For instance, drilling down 3 hierarchy levels reveals a cluster of media related to air travel associated with a single legal entity, the Vienna International Airport. But we can also observe clusters about sports and military. Or organic food. For our insight-based evaluation, we used 2 subsets of the media transparency database. The first data set comprised only advertising objectives and contained over 1,000 legal entities and over 3,000 media organizations. The second data set only contained press subsidies and was therefore smaller with 68 legal entities and almost 900 media organizations. We retrieved almost 5,000 authors and over 2,000 key terms from the IEEE Visualization Publications database to visualize commonalities between authors and research topics. The database can be explored to find research topic clusters and their associated main authors, such as engines and automotive engineering. Or time series analysis and statistical analysis in vast publications.